Good day, dear students. As per our extension in problem solving for SFEE equation, so we are remaining with last two problems, and the last problem is second last problem is concerned with the nozzle, the air flowing through the nozzle. So this is question number 544 in your problem set, and it says that the air, the working fluid, is going into a nozzle at a velocity of 10, pressure 800 kilopascal, temperature at 400. Now it is been flowing through the nozzle. The outlet pressure is 20 kilopascal, the temperature is 300 degree, and while the flow is happening, the heat is rejected from the nozzle. The heat rejected from the nozzle is 25 kilowatts. Okay. Inlet area given to you is 800 centimeters square, and outlet area been not given to you. What is asked in the question is to find out the velocity at the outlet. So what I am going to do, I am going to indicate the velocity by bar. So this is V2 bar. So we don't get confused between velocity and volume. Second thing that what they have asked to find out is the volume flow rate. Now the volume flow rate you can determine in terms of meter cube per second, or it may be a specific volume flow rate, that is meter cube per kg. That depends upon the availability of the m dot and parameter value, etc. Let us proceed to the solution part. So now quickly what we can see is, if the area A1 is known and velocity V1 is known, we can immediately go and find out the discharge value. So if I try to find out Q, that is discharge at point number 1, that will be equal to area at point number 1 multiplied by V bar 1. So area at point number 1 given is 800 centimeters square. So this is 800 into 10 to the power minus 4 multiplied by V1 bar, velocity at point 1 is 10 meters per second. So the value of Q discharge at point number 1 is equal to 0.8 meter cube per second. Now if we know the value of discharge, and we know a very well known empirical relation, that is what we used to use generally, m dot is equal to rho into A into V bar. Now we can put over here as A1 V1 bar or A2 V2 bar, it depends on you. Density, since the working fluid is nothing but air, so density is 1.2 kg per meter cube. Let's go and find out the value of m dot. So m dot is equal to 1.2 multiplied by A1 into V1. Directly I can write it as Q discharge. So m dot is equal to 1.2 multiplied by 0.8. So m dot will become 0.96 kgs per second. Now let's go and see whether we can find the value of V2 bar. Now the value of V2 bar, if we are known with A2 and if we are known with Q2, if A2 would be known, Q would be known, then V2 bar can be easily determined, but we are unavailable with that as of now. If I try to apply the first the SFEE to the system which is given over here. So if I try to apply the SFEE to this nozzle, what we can write down is summation Q minus summation W is equal to delta H plus delta KE, and delta PE can be tapped generally as 0. Summation Q, so heat is given out of the system. Now we have seen that either we can play a blind fold with sign conventions, and whatever value we get we can interpret the sign convention, we can interpret the in and out depending on that. That is one method as we have learned. The second method is that right from the start you implement the sign convention, because if you are implementing right from the start, then you should know the direction of all the parameters involved in the equation. So we try to use this strategy as of this problem. So we use the sign conventions. If I am using the sign convention, the heat is rejected by the system. Heat added to the system is taken as positive and heat rejected by the system is taken as negative. So in place of Q, I am going to write it as minus 25, and that into 10 to the power 3. I will just mind it that it is in watts. Now this will be equal to H2 minus H1 H2 minus H1 plus delta KE can be written as half m dot V2 square minus V1 square. Now as we know the value of velocity at point number 1, as we know the value of m dot, let us put it and let's see. So this is minus 25 into 10 to the power 3 is equal to H2 minus H1 plus half m dot is 0.96 multiplied by V2 is unknown and V1 which is known is 10 square. Now I'll maintain this as equation number 1 in order to find out V2, provided I have a value of H2 and I have a value of H1. Let's see if we can calculate the value of H2 and H1 or not. So H2 or H1. Enthalpy, generally we know that it is given by m dot Cp, or I can say delta H is given by m dot Cp into delta T. Let's go for H2 minus H1. So H2 minus H1 is equal to m dot into Cp into T2 minus T1. H2 minus H1 can be written as m dot is 0.96 multiplied by Cp of air. I can go for it as 1.005 10 to the power 3 as we all know, multiplied by T2 minus T1. So T2 over here is 300 minus T1 is 400. So H2 minus H1 is equal to this value. Nine six 410 4180. So the unit is joules per kg. Is it having any 10 raised to 3 or 4? That's it, minus. Okay, I'll try and substitute this value in our equation number 1. Equation number 1 is minus 25 into 10 to the power 3 is equal to H2 minus H1 minus 96480, provided, mind it that it is in joules per kg. So if you multiply this by m dot, that is kgs per second, you will get the unit as watts. So left hand side is also having watts. So this is over here plus half into 0.96 V2 square minus 10 square. Now I'll put up all the mathematical parameters which are known. So it is minus 25 into 10 to the power 3 plus 96480 multiplied by m dot is 0.96. This bracket multiplied by 2 divided by 0.96 plus 10 square is equal to V2 square. So tell me the value of V2 square first and then V2. One 40976.66. Square root of that. 375.4 meters per second. Okay, so that's a huge increase in the velocity. Now we go to the second term, that is the volume flow rate. Volume flow rate, it means, okay, volume flow rate is meter cube per second. It's a flow rate. So meter cube per second is nothing but the discharge value. So we have already calculated the discharge value, and this is meter cube per second. So this is already second answer we have already calculated, and this is the value of your V2.